So for intervention today, you're going to do notes. I have provided a blank copy, so all you need to do is fill in what I fill in. You should see everything else is the exact same. So the first things first is 8.f.a is the standard we're going to be looking at. And your I can statement is I can define a function as a rule where each input there is exactly one output. So again, anytime that I go too quickly and you need to pause and get all that information down, you're welcome to do so. So the definition of a function is basically exactly what your I can statement is. Each input has only one output. Now, normally we don't think of things in terms of input and output. We think of them in terms of points, in terms of graphs, in terms of other things. So when we think about a point, our input is our x coordinate. So what number are we putting into the equation? So what number do we get out? Well, in an equation, normally it's going to be your y value. Same thing with an ordered pair. When your x is, say, 0, your y is 5. Or your answer is 5. So whenever you plug in a 0 to this function, you get out the number 5. So we got ordered pairs, tables, and maps. So we got 4 different examples here for ordered pairs, tables, and then this is your mapping diagram. So if we look at the first one, we have the point 0, 5, 3, 5, 4, 5, and negative 3, 5. So again, each input or x value has only one output. Well, your first column is going to be x. And your second column is going to be y's. So 0 has one output of 5. Notice how there's no other 0. So the only answer for 0 is 5. 3 is the same thing. The only answer for 3 is 5. Now notice that we have a negative 3 down here, but 3 and negative 3 are two different numbers. So each x, positive 3, has only one output. So 4 is the same thing. 4 has one output of 5, and negative 3 has one output of 5. So does each input have only one output? The answer is yes. So this would be a function. Now if we look at the second one, that's an example of a table. Notice how you have your x and your y on each side. So we have our x's are our inputs, and we have our outputs here. So negative 2 is the input, 1 is the output. We have no other negative 2's, so we know that negative 2 has the one output of 1. 2 has one output of 2. Notice how negative 2 and positive 2 are different, and there's no other 2's. But then we should start to see that we have 2 4's. So when I plugged in 4 the first time, I got out 3. When I plugged in 4 the second time, I got 4. So this would make it not a function because each input, so 4, does not have one output. It has 2 in this case. So number 3 is negative 1, 1, 3, 5, negative 1, 9, and 6, negative 4. So same thing as your ordered pairs from number 1, they're just turned sideways. So x comes first, and then y, xy, xy, and xy. So again, it's about the inputs. So negative 1 has an output of 1. Now, do we see any other negative 1's here? Yes, we should see it in the third point. So negative 1 also has an output of 9. So if it has 2 answers or 2 outputs, that would make it also not a function. So again, it's about having multiple x values. So this and this is where we're looking at because that's not a function. Now, your mapping diagram looks a little bit different. Obviously, it kind of shows from one to the other where it's going. So the first one's going to be x, and the second one's going to be y. So 5 goes to negative 6. It's got one output. -2 goes to -1, 1 output. And 7 to 8, 1 output. So yes, this would be a function. Each input has 1 output. So again, it's more about your x's being the same, not necessarily your y's being the same. So if we look at our graphs, I'm going to scoot this up. Graphs, we perform the vertical line test. So we draw vertical lines, and vertical is straight up and down. And if each line crosses once and only once, then we have a function. So again, it's all about this idea of once. So if we look at our graph here, so the grid lines stay the exact same on all 3 graphs. So that's not what we're talking about at intersecting or crossing. All we're talking about is this graphed line right here. So to help, I'm gonna do, and if you have a highlighter, so that's what I'm testing for the first one. That's what I'm testing for the second. And that's what I'm testing for the third. So again, not the black lines underneath, the cross and the T marks, just the graphed lines. So if we take our pen and we draw some dotted lines. So we're drawing vertical lines through the graph. So this yellow line and this first pink line intersect once. The second line intersects once, the third once, and the fourth once. So even though we have it intersecting 4 times and we say it only needs to be once, each of those vertical lines only hits once, and that's what we want. So yes, this would be a function. So the next one, we'll draw vertical lines again. Now, if we look at the first vertical line that we drew, it intersects with the yellow line once and twice. If we look at the second one, it also intersects once and twice. So since it intersects twice, this would not be a function. Because again, your rule is that each line can cross once, and this one crosses twice. Now the last one is a little bit tricky. Notice how it is a straight vertical line. So if we draw a vertical line over our vertical line, it kind of goes away and kind of hides itself. Well, basically what that means is that this vertical line is crossing at every single point. So if it's crossing at every single point, then it definitely crosses more than once. So no, this would not be a function. And the last one is you can test your equations with your points, because again, x is input, y is output. So for equations, all you do is plug in your x and y. So for A, your y value would be -11, and your x value would be -2. So we got -2 squared minus 7. So -2 times -2 should make a +4. And 4 minus 7 should make -3. So does -11 equal -3? No. So these points, this table does not work with this equation. So this is not the correct answer. So if we look at option B, we can pick our points. So y again is a -11. X is -2. And so we got 3 times -2 minus 5. So again, all I did was take x and make it a -2. So then we simplify. 3 times -2 is -6. -6 minus 5 is going to be -11. So does negative 11 equal negative 11? The answer is yes. So at this point, we know that this point works in that equation, but not all of the points could. So we do need to test a couple of them. So we got y equals 3x minus 5. So let's pick the bottom one. So y is 4, x is 3. So I input 3 into the equation, and I should get out 4 if this is the correct function. So 3 times 3 we know is 9. 9 minus 5 we know is 4. So 4 does equal 4. So we know that both of these 2 points work. And I'll give you a little heads up, all the rest of them do as well because I tested it. So B is the correct equation for that formula. So in just a second, I'm going to tell you what your codes are, or hopefully I'm going to put it online somewhere. But if you need to go back and rewatch any of this, but you are going to do a Mastery Connect 10-question quiz. Both of these things are going to be graded, so make sure that you have completed all of your notes. So anything that I wrote in pink should be on your paper, and make sure that you complete the 10-question Mastery Connect. I should give you your codes here in just a minute, or you should be able to find them on Canvas under your intervention course. Thank you.